Let's do a freezing point depression calculation. What's the freezing point of a solution formed when 25 grams of glucose dissolves in 200 milliliters of carbon tetrachloride? The density of CCl4 is given, and again our KF data are in that handout on D2L. So the first thing we need to do is need to calculate the molality. So I take my grams, 25 grams, convert it to moles, that's the molar mass right there. And now I need to know the mass of the solvent, which is CCl4. So how do I turn that 200 milliliter volume into a mass? Well, mass is volume times density. So that 200 milliliters times 1.587 grams per milliliter, right, that's the density, gives me the mass. So that 200 milliliters has a mass of 317.4 grams, or 3.714 kilograms. Now we need to calculate molality. So moles over kilograms, so 0.438 molal. Now, glucose is not ionic, right? That's a molecular substance. So it'll dissolve, but it does not dissociate. So we don't need to multiply this number by anything because there are no ions. Okay, so now we just solve. What is our change in freezing point? It's the KF value for CCl4, which is from that handout on D2L, times the molality that we just calculated. So when you multiply those two numbers together, you get 13.14. And now we subtract that from the normal freezing point. You probably don't know the normal freezing point of carbon tetrachloride off the top of your head, so you look it up in that chart on D2L. Normal freezing point is negative 22.99 degrees Celsius. We're going to subtract that delta TF from it. So the freezing point of this solution is negative 36.13 degrees Celsius.